To solve a formula, something like 3x minus 4y is equal to 12, the idea is to choose one of the variables, either in this case x or y, and isolate it to get it by itself on one side of the equation. So we can use all of the concepts that we did for solving a linear equation. The only difference is our answer won't be a number, it'll involve some other variable. So let's check this out. We have 3x minus 4y is 12, and let's first choose x to solve for. So I see 3x is located right here, meaning I can add this 4y to both sides of my equation. That is, I'll add 4y on the left and 4y on the right and simplify what we have. We're left over with 3x, the 4y's cancel, and on the right I have 12, I have 4y, those are not like terms, so I can't combine those any further. To get x by itself, I'm going to divide both sides by 3. On the left, the 3's cancel, leave me with just a 1x. And on the right, I have 12 plus 4y divided by 3. And we can leave our answer like this, because 12 and 4y are not like terms. Dividing by 3 is probably the simplest way to write it. But we've done it. We had this formula to begin with, and we changed it so x was by itself. So there was nothing special about choosing x. You could very well have picked y and solve for that. So let's just kind of run through that again with this problem. I'll copy it down again. We have 3x minus 4y is equal to 12. So you could also solve this thing for y. To do that, I'm going to, I think, subtract 3x from both sides of my equation. I end up with, on the left, negative 4y, and then I have 12 minus 3x. To get y by itself, I can divide both sides by negative 4. And here on the left, the negatives cancel, so do the 4's. It's just a 1 next to the y, so I'm just going to put y. On the other side, I have 12 minus 3x divided by negative 4. So we have our answer. I think I'm going to write it in a slightly different way, where I'm going to take this negative and instead write it in front of the fraction just so it looks a little bit neater. This is y is equal to, it's 12 minus 3x divided by 4, but I'll just say that the entire answer is negative. You could also, if you would like, multiply this negative to both terms in the numerator and write it as negative 12 plus 3x divided by 4. But really, I'm fine with just leaving it as this for now, where, okay, we got y by itself, we have everything else on the other side, and that's my solution. And for the second example here, now our formula that's given in the question, a is equal to h divided by 2 times a plus b. This formula has some context. It's the formula for the area of a trapezoid. So I'll sketch one of those. So this is the shape of a trapezoid. H in the formula would represent the height, that's the distance from the bottom to the top. The values of a and b represent the lengths of the top and the bottom. So I'll say that this is h, this is a, and this is b. If you know those values, you can plug them into this formula to determine what the area of this object is. But for this question, really all I'm looking to do is, I want to rewrite the formula. I want to take this equation and solve it for, I'm going to choose b. The goal is to get this by itself on one side of the equation. All right, so let's see. A is equal to h over 2 times a plus b. I think maybe the first thing to do is, well, I see that h over 2 is multiplied to this thing with parentheses. I think I'm going to distribute that in. I'll write this as a over 1 and b over 1. So I'm multiplying this in front of both terms. I have a is equal to h over 2 times a over 1 plus h over 2 times b over 1. And we can further write this as, okay, the first fraction, if I multiply a and h, well, the best you can write that is just ha like this, and the denominator is 2 times 1, which is 2, just trying to express it as one fraction. And I can do the same thing for the second piece. It's h times b, all divided by 2. So this is kind of messy looking, but just keeping in mind that the ultimate goal is to get this by itself. So first, if I want to isolate this piece here, I need to get rid of this expression. So what do I do to both sides of my equation to remove this? I'm going to subtract it from both sides. All right. On the right side, they cancel. This minus this just goes away completely, and I'm left with, on the right side, h times b over 2. Now, on the left, I have a. I'm subtracting h times a over 2, and there are no like terms anywhere between those two, and I therefore can't combine it any further. But I want to keep in mind what my ultimate goal is. I want to get b by itself. So I'm looking at this term. Maybe I'll do 2 steps where I want to cancel this 2 first. And that means I'm going to multiply both sides by 2. So what do we have? Put that over here. But if I double both sides, that's 2 times a minus 2 over 1 times ha over 2. And that's equal to 2 over 1 times hb over 2. So I doubled both sides, just basically put a 2 in front of every single term, and wherever there was a fraction, I just wrote 2 as 2 over 1. If I do this, well, I know the 2 cancels here, and they also cancel here, so I have 2a minus ha is equal to hb. And we're very close to our final answer. If I'm looking to get b by itself, and there's this value h in front of it, I can divide both sides by h to isolate b. So let's do that. I'm going to divide the left side by h. I'm going to divide the right side by h as well. So the h's cancel, and I'm left with b. I'll put that here. That is my final answer. 2a minus ha all over h is b. So this is, a more involved expression, but the ideas are the same. So, just to kind of recap here, I wanted to get rid of all of the stuff on this side except for b, but I had to distribute this h over 2 in first. Once I did that, I combined them into a couple of fractions, and that way I could see what I had to do to both sides. I had to get rid of this, so I subtracted it from both sides. I then wanted to get rid of this 2 and this h, so I first multiplied both sides by 2, and then I divided both sides by h.